Welcome to the third part. Now we are discussing about the next topic, that is called as dimensional equation. So what is a dimensional equation? Whenever a physical quantity is equated with its dimensional formula, we get an equation which is called a dimensional equation. So in order to get a dimensional equation with the help of dimensional formula of a physical quantity, what we have to do, we have to select a proper symbol for the given physical quantity, also enclose it inside a square bracket, and then equate it equal to its own dimensional formula. The expression which we will get now, it will be called as the dimensional equation. For example, dimensional formula of the force is m1 l1 t minus 2. So if we select a proper symbol for the force, say F, and also enclose it inside the square bracket, and then we equate it equal to the dimensional formula, then this expression which we are getting, we call this as the dimensional equation for the force. Similarly, dimensional formula for the acceleration is L1 t minus 2. We want to write its dimensional equation. What we have to do, we have to choose a proper symbol for the acceleration and express it inside the square bracket. So we are choosing small a for the acceleration, enclosing it inside the square bracket, and then making it equal to its own dimensional formula. Then we get dimensional equation for the acceleration. So in this way we can write down dimensional equation for various fundamental or the derived physical quantities. Next, we are starting with some basic definitions. First, we are talking about dimensional constants. Dimensional constant means there are certain physical quantities whose value is fixed permanently. There is no change in the value of those physical quantities, but these physical quantities also possesses dimensions. These types of physical quantities with constant value but possessing dimensions, we call them as the dimensional constants. For example, Planck's constant. Planck's constant has a fixed value of 6.63 into 10 raised to power minus 34 joule second, but it also possesses dimensions. That means we can write out its dimensional formula, which is m1 l2 t minus 1. Another example, simple example, speed of light. Speed of light is fixed 3 into 10 raised to power 8 meter per second in the vacuum, and we can write down its dimensional formula L1 t minus 1. So those physical quantities which possesses constant or fixed values but also have dimensions, we call them as dimensional constants. Then there are dimensionless constants also. These are the physical quantities which possess fixed value, constant values, but do not have any kind of dimensional formula associated with them. For example, pi, which is 3.14, which is a fixed number, no dimensional formula. Then exponential factor e, which has a fixed value of 2.71. And also the numbers like 1, 2, 3, 4, 5, 6. These are having fixed values but do not possess any dimensions. Next, dimensional variables. These are the physical quantities whose value varies from according to the situation, but they also possesses the dimensional formula. For example, area, velocity, volume, acceleration, time, force, pressure, linear momentum. These quantities fall into the category of dimensional variables. Then at last, we are having dimensionless variables. So these are the physical quantities which possess variable values but do not have any kind of dimensions associated with them. For example, angle. Angle is the ratio of length of arc to the radius of arc. So it is a ratio of two similar quantities. So it has got no units, no dimensions. So it is a dimensionless variable. Then there is strain, refractive index of a liquid, mechanical advantage for a machine, or the velocity ratio. They fall into the category of dimensionless variables. So we have dimensional constants also, dimensionless constants also, and on the other side we have dimensional variables and non-dimensional variables are also there.